Welcome to this PanelPilotACE tutorial. Now in this tutorial I'm going to be showing you how to use the maths functionality which has been made available in the latest version of the beta of the software, which is now for download on our website. Then there's a couple of steps to actually implementing an expression, a maths expression, and I just want to show you those so that you can start to use that in your projects. So the project I'm going to demonstrate this in is a simple power monitoring application. So I'm going to set up a new project. Let's just change a couple of these. Let's change the background color, and I'm going to set 3 boxes here to have our 3 readings in. So I'm going to have voltage, current, and of course power. So I'm just going to control and copy these. Don't need this to be too precise for demonstration purposes, but I do like things to look reasonably neat. Okay, so we've got our 3 boxes. First thing we're going to do is we'll put the units in here. So we'll put V for volts. I'm just going to change the color of that to white. Resize this text box a little bit. In fact, I'll put that one up here. Copy that, change that for current. Actually, just put that A for amps. And then finally we'll have this one for power. So we'll change that to W. Now I should really go and change all of these text boxes to give them unique identifiers, but for the purposes of the demonstration, to keep things nice and quick, I will just move ahead and I will name the text boxes that we're going to use for the actual readings. So I'm going to name this one volts reading. Again, change the color of it to white, just look better on that blue background. And I'm going to increase the size of that to 40. I tend to, I mean, you don't need to do this, but I tend to just put the format of the text that is likely to appear in the text box, because obviously I'm going to equate this text box to an analog input in a moment. And I'll copy that. Current reading, change that there, and then one more text box required for the power. So as mentioned, I'm going to use 2 analog inputs, one for the voltage, one for the current. So I go down here in my library and select analog input. I'm going to just double click that twice to bring it in. So we're going to use the first channel for volts. I'm going to set my range 0 to 10 volts. The analog input 2, we'll use this one, that's going to be current. And again, I'll set this 0 to 10 volts. Obviously, depending on how you have your actual application scaled, these might vary. The next thing to do is to set up the first 2, so the volts and the current, as digital displays. So again, just double click on that from the library, volts digital. I'm going to set that, equate that to the analog input element. Now what I'm going to do here actually is I'm going to effectively in our application pretend that we have a 240 volt AC signal that we're equating to 0 to 10 volts. So I'm going to replace the scaling here. So at 0 volts we read 0, and at 10 volts we read 240. And then in the text element I'm going to choose the volts reading here. I'm going to reduce the the decimal places to 1. And then we do the same with the second digital readout. So another double click here, current digital, select the second analog input, 0 to 0, 10 volts will equate that. Let's say that's going to be 5 amps, and equate that to the current reading. Again, just change that to 1 decimal place. Right, so we now have our 2 analog inputs set up, and you can see here, if I come down here and I can emulate the runtime here and use my sliders to demonstrate our 2 scales. As you can see, at the moment this text box here, which is showing the power, it's basically just a static text box at the moment. So what we want to do here is, in the library and in the function element of the library, we come down here and we double click on the mathematics builder. Now this feature is still in beta. It's one of the major advances in this beta. There are a couple of little things that we're looking to tune before the release version, but it is usable, very much so. And but if you do find anything that you think that we could improve or change, please do let us know. So I've just double clicked to add a new expression here, and then I can select any of the different elements from these drop downs. So I could select a constant, I could select a function. So we've got various trigonometric functions and logarithmic functions. I don't have any variables. I could use a variable from a project, but in this case what I'm looking to do is to take the scaled reading, and I'm going to obviously be multiplying the volts by the current. So come down here, and what I actually want to do here is choose the volts digital, so the actual digital reading, because that's after we've done the scaling. And I can choose any property from this. So in this case the scaled analog input value is the one that we want. And oops, excuse me. So up here, and then we're going to add a second one, so we need to multiply that, and then the third part of the expression is to go and select the current digital reading, and again scaled analog input voltage. Now the way that this works is this will effectively carry out this calculation whenever it's called. So to call this, we need to do 2 things. The first thing that we need to do is we need to tell it what to do with the calculation after it's finished with it. So in the action set rules, we'll go up here and we're going to create an expression whereby we take a property, and in this case we want it to be the text box that's used for to display the power reading, and we set the property to text, and we want to say we want that text box to equal the property of the maths function and the value that calculates. And it's all well and good, but we now need to actually call that action, and there's 2 ways we can do that. We've either got a properties trigger, so we could set, using the properties trigger, we could set it to run that action whenever a hardware input changes, so for example an analog input changing. But because we've got 2 analog inputs, what I'm going to do in this case is use a timer. So I'm going to run this every quarter of a second, so 250 milliseconds, and I'm going to call logic actions, and that logic action will equate the text box to the maths function that we've set up. Now this may seem like a slightly long-winded way of going about it, but we're all about trying to give flexibility to the design here, and by keeping elements separate, not only does it mean that we can keep the number of elements down that are in the library so that it's easier, you'll get used to working with the same ones, but it also gives you flexibility to use them in a lot of different ways. So you can see here I can change my voltage, and as I increase the current, you can see here the power that we're taking is increasing. Now with this being a beta, there are some issues at the moment. The main one here is that we can't suppress the decimal places at the moment. There is a workaround. This will be fixed in time for the proper release, but in the meantime we go in here and we can use a string converter, and again we want to equate this to the maths reader value, and then what I can do is actually tune the string that comes out of the maths builder to my requirements. This is going to be something that will be useful, particularly with serial interfacing, which is another thing that's been added with this. So I'm going to go down here and reduce the decimal places to 1, and then I need to change my set rule expression here to the string converter value. So string converter value, so again I'm just equating my text box to that adjusted string. So you can see now as I move that up we have a calculated value, volts times amps equals watts. Thanks very much.